you have a nested struct with an order with a customer, an address, and a list of items. Now you want to see what's inside. The first thought that comes to your mind is that you might want to use the printf method and use the %+v to print that out. If we do that, let's see how it would look like. You can see here, we get back the result, but it's not that easy to read. Is there any other way we can improve this? Some developers, they would start splitting it up in multiple print statements. It would look something like this. Now, if we run it again, we can see it's quite easy to read. But the problem with this is every time the struct changes, you also have to update these print statements. And there is a lot of code here just to print out the values in this struct. But what if I told you there's a better way to do this? And that is by using a library called godump. So godump is a developer-friendly, zero-dependency debug dumper for Go. And it's extremely simple to use, and it just works. Let's see it in action. The first thing we need to do is we need to install it. We can say go get github.com/go/godump. What we can do now is we can just replace these print statements. So here I will clear it. Then we can just write godump.dump, and then we pass our order here, so order. Before we can use the library, we just need to import it first. Click add import, and then if I scroll to the top, I can then see it's been imported here. And then I will run it, so go run main.go, and that is very nice with just one line. Now we have colors, and it's indented, so it's easy to read. It also shows the different types. So here it says int, customer, string, address, and so on. And we can also see what file this debug output come from. Here it says main.go, and it's on row 45. Another useful thing is, let's say you just want to inspect something, and then you want to stop the program. So first I will just add a print statement here, print line, and then I will say this will not run. And instead of saying dump, I can just say d, and that stands for dump and die. If we now run it again, we can then see we get our output, and then here it says exit status 1, and this statement here is never run. And one of my favorite things is you can compare values. So let's just clear the terminal here, and then I will delete this code here. Let's create two orders. So here I have order 1 and order 2. And let's say I want to know the difference between these orders. What I can do is go dump and then use the diff. So diff, and I will pass order 1, and then I will pass order 2. Let's now run it. And now we get highlighted what are the difference between these orders here. And take notice of this. This is Patrick with a K. The diff catches everything. And what about circular references? Let's first just clear here. And then we have this code here. You can imagine we have a node struct, and this node struct have name, children, and parent. So we start by creating a parent node, and then we create a child node. And this child node is reference the parent. And then we set parent children to also reference the child, making it a circular reference. If we would print out this with printf, this is what we would get. And all we get now is a memory address. And if we instead would use the godump, so godump and then dump parent, let's run this. We can then see we get a much more clearer output. And it takes care of the circular references for you. And what I love about godump, it just works out of the box and it looks great. However, if you want to customize it, that is also possible. If we look here at the documentation, you can say godump and new dumper. And then, for example, here you can specify the max depth, max items, should it be with color, and so on. The next time you are reaching for printf to do some debugging, it might be worth installing this zero dependencies library instead.